All right, the final section, I think is the easiest section in this chapter. It's all about symmetry. Right? So line symmetry and rotational symmetry. Right? So symmetry is all about mapping a figure onto itself. If we're talking about line symmetry, we want to think about if I can draw a line through the figure and fold over that line, and the figure sits on top of that half, right? So, for example, in this heart, if I draw a line right down the middle and fold over that line, each half of the figure would map onto itself, and it would sit exactly on top of itself. So, okay, we want to figure out whether each of these has line symmetry. Okay, what the lines of symmetry each one has. Okay, so let's just take a couple of minutes, okay, and see if we can find all of the lines of symmetry for each of these figures. Okay, and there can be more than one line of symmetry.
What? We're going on top of each other's. Did you leave last night because it was after me? What?
My first group was pretty hard.
I literally used to check and Greg.
It's pretty hard.
You're the coach too? How many people in your class? My biggest class is either Spanish or global studies. I don't know. Our Spanish class is full.
It's not full, I can tell you that. We're literally in the first two rows. And even then, there's only like 4 people on
So there's 1, 2, 3, 4.
8, 9, there's like 11 of us.
I can't. Is there a real behind me?
It's like when we're making our schedule.
So as I was walking around, these seems like these are a little bit harder than you may have anticipated. Right? I've seen a lot of wrong answers as I was walking around. So for the first one, how many lines of reflection did we get? 5. There are 5 lines of reflection for number 1. Okay, we can draw a line right down the middle like that, right? But I can do that same thing 5 times. I can draw a line right here. And if I fold across that line, it'll match up. I can draw a line through here. And if I fold across that line, it'll match up. I can actually do that from every single corner to the middle of the opposite side. Okay, so it'll be a perfectly straight line. Okay, we end up with 5 lines of reflection here. Okay, it may be easier to visualize if you rotate your paper a little bit. If you put this point up at the top, it's going to look exactly the same. Okay, so there are actually 5 lines of reflection for number 1. How about for number 2? All of them?
You can't fold nicely. It's 2. It's 2.
There are 2 lines of reflection for number 2.
I can fold it like that though.
No, it won't line up nicely. Fold
So the only 2 lines of reflection for number 2 are going to be like this. Okay? If it's tough to visualize, take a piece of paper and fold it corner to corner. Right? A piece of paper is a rectangle. So if you fold a piece of paper corner to corner, it's not going to match up. Yeah, exactly. It doesn't match up.
if you believe hard enough.
If you believe hard.
2 questions. Can the test technically correct? Can it be the entire test? And second, can it be 100 points?
This will not be the entire test. It will not be 90% of the
I'm
test.
gonna fail the test every time I do.
Probably not. How about number 3? How many lines of reflection did we get for number 3? So I'm
What
here
if you went up through the
0 and
middle?
2.
What if you went through the middle, Peter?
That doesn't work out.
That does.
There are 0 lines of reflection. Right down the middle, like this.
No, wait, another way. I don't know. I was like,
That's what I was thinking because I flipped paper and they lined up.
yeah.
So it kind of looks like we may have one right down the middle, like this. Okay, if I were to take, say, this point and go that distance to the line of reflection, and then go that same distance, it would match up. But if I take some point on the middle bar, right, and I go that same distance, definitely doesn't match up. Okay, so this one does not have any lines of reflection. How about number 4? Okay, number 4, there are no lines of reflection on that one either. Good. Okay, so on these, okay, I mean, you can actually take your paper and fold it over and see if it matches up. Or, okay, you can try to use our rules that we've been talking about for reflections. Okay, the big idea is, especially for this one, right? Just if you think this is a line of reflection, pick out a point, okay? Go that same distance to the line of reflection and see if there's a point on the other side, right? In this case, there's not. Okay, so you can check yourself using our rules of reflections that we've been talking about. So the other type of this looks like it. There we go. The other type of symmetry is rotational symmetry. Okay, so on the back, if we can rotate a figure less than 360 degrees and it looks exactly the same as where we started, then it has rotational symmetry. Right? If I take a figure and rotate it 360 degrees, obviously it's going to sit on top of itself. Right? So every single figure ever has 360 degree rotational symmetry. Right? That's just rotating it a full turn and putting it back on top of itself. So what we're interested in is, can I rotate it less than 360 and it looks exactly the same? Okay, so the way that we determine, okay, I mean, we just want to look at our figure. Okay, we can actually rotate our paper, see if it looks exactly the same. So in this example, if I were to take, this piece 90 degrees, it'll look exactly the same. Right? Essentially, we're just looking at kind of one side of the figure or one piece of the figure and seeing how far I need to rotate it. A couple of vocab words. Okay, the order of symmetry is the number of times a figure maps onto itself between 0 and 360. So essentially, what we're doing, okay, is just looking at how many things around the edge of the figure we have that are exactly the same. So in this case, there are 4 identical sides to this figure. Okay? So we would say the order of this figure is 4. Then to figure out the rotational symmetry, we just take 360 divided by the order. So that would tell me 360 divided by 4 is 90. The order of symmetry of this figure is 4, and it has 90-degree rotational symmetry. Okay, that means I can rotate it 4 times, and it'll look exactly the same before I get all the way back around. Okay? So, if we look down at, I guess I also should mention, we're assuming that we're rotating about the center of the figure. So essentially, we're sticking our finger in the middle of the figure and rotating it about the center of the figure. Okay, we're not doing a rotation about the origin or anything like that. We're assuming that we're rotating about the center of the figure. Okay? So if we look down at our examples here, okay, we just want to figure out if the figure has rotational symmetry, and if it does, what the order is. Okay, so let's take a few minutes and see if we can figure these ones out. So in order of 1, would just mean that every single figure ever has 360 degrees because we rotate it all the way around and sit on top of it. So we would say no.
Divided by 70 is not 260. No, I was.
what did we get for number 1? Does this have rotational symmetry? Yes. How many? 90?
45.
45.
I think it's going to be 45. Okay, so the center of symmetry would be the middle. So if I count these identical things all the way around, there are 8 of them. So we would say the order is 8. So then if I take 360 divided by 8, that means that the magnitude of symmetry is 45 degrees. How about number 2? No. So technically every figure has 360 degree rotational symmetry. So we would say that this does not have rotational symmetry. Would this have any lines of reflection? Yeah, this one would have reflectional symmetry, right? But not rotational symmetry. How about number 3? This one does have rotational symmetry. So we would say the order is 2. And that means the magnitude would be 360 divided by 2, which would be 180. If I flip it upside down, it would look exactly the same. If I rotate it 180 degrees. What about any line symmetry? Does that one have line symmetry?
No.
Ooh, I heard some yeses and some nos. Right down the middle. So if I draw a line right down the middle and I choose a point, wait, which one?
It's like this.
Oh, well, it's the same idea. Right, it's not going to match up if I fold it across that line. Okay, so this figure would have rotational symmetry, but not line symmetry. How about number 4? Does this have rotational symmetry? Yes. It has 180 degree rotation. No, number 4. No, we already did 3. 120. Okay. So if we look at it now, does this have rotational symmetry? I think the answer is no. I don't think this has any rotational symmetry. What about line symmetry? Does this have line symmetry? I don't think it'll have line symmetry either. This looks like a scalene triangle. All 3 sides look like they're different lengths. So I don't think it's going to have any line symmetry either. Okay? Any questions?